variable, operations. Operations means the in between plus minus signs and all. Great. And what else did we do? The degree of a polynomial we did yesterday.
Yes, ma'am. And polynomials in 1-2 variables.
So the highest, whichever polynomial has the highest power, that becomes the degree of the polynomial.
Yes.
And did we do this also? That linear polynomial has degree.
And we have to do from degree of the polynomial. We still have the third question left.
Yes, what? Yes, Rohit.
Yesterday we did till make a monomial with degree 35 and degree 100. We have the next questions left.
That was a exercise question.
Yes, ma'am.
Okay. So I would like to add on to it. Suppose we have, चलो अभी मैं आपको करके बताती हूँ. Let's do. I'll share the screen. Okay. This is what we did yesterday, right?
Yes.
Ma'am, are you sharing anything?
Exercise questions. Okay. With power 35, with power 100. Okay. Now I would say one more thing. Now, suppose this, if you have this kind of polynomial, I'm just taking one polynomial. This is a polynomial. Its degree, highest degree is what? 1. Okay, highest degree is 1 here. Variable,
Yes, ma'am.
the highest degree is 1. So we call this type of polynomial as a linear polynomial. Okay, we call it as a linear polynomial. And for questions where you have highest power as, suppose I've taken this polynomial, I'm taking the highest power as 2. That means this type of this polynomial, the highest degree is 2. We call such polynomials as quadratic polynomials. Okay,
Ma'am, we have done this.
we have done quadratic polynomials. And
Ma'am, you said that the polynomial with the highest power 3 is called cubic polynomial.
the highest power is called cubic polynomial. Okay.
And for 4 it's biquadratic.
Okay, and one more thing now. If the polynomial is linear, then it will have only one 0. We call 0 of a polynomial. 0 of a polynomial. 0 means the root of a polynomial, the answer of the polynomial. We find out the value. That means 0 of the polynomial means that value of the variable at which the polynomial equation becomes equal to 0. Right?
Ma'am, so then if linear has 1 0, then quadratic has 2.
Yes, for linear polynomial will have 1 0, quadratic polynomial will have 2 zeros, okay, and cubic polynomial will have 3 zeros.
Ma'am, then here we consider this 0 to be the root of the variable.
Zeros are also called the root of the polynomial. Yes, that's nice that you remember. Very good, Sampath. Great. Okay, so we'll move ahead with this. Coming to the chapter part, let's see some questions. Okay. So in this exercise 2.1, I had told you to complete 2.1 exercise. Did you all do that? In the homework I had given you to complete exercise 2.1.
Yes, ma'am.
Great. Okay, so now moving to zeros of a polynomial. So now exercise 2.2. We'll do some questions of 2.2 also, and the remaining left ones that you will do. And please do the examples of the book also. Okay. Examples of the book are very important.
Okay, ma'am.
Okay, now in this we have the first question. Find the value of the polynomial. Now this is the polynomial. Find the value of this polynomial at x equals to 0, x equals to -1, and x equals to 2. That means at these 3 points, we have to find the value of this polynomial equation. Now you can see we write polynomial equation as px like this. Okay. Why do we write px? Because the polynomial equation is in terms of x. So if we have to find for 0, x equals to 0. So wherever we
And then
have
if the variable changes, then
just a second. Wherever we have x, in place of x, we will write 0, right? And in the equation, we will put the value of 0 and see, we will check whether this equation becomes equals to 0 or not. Okay? Yes, now ask what you are asking.
ma'am, if we are writing P of X, ma'am, here P, can you say what is again?
3, this 3,
No, ma'am, P means what, ma'am?
1 second, I am not getting you. 1 second.
Ma'am,
Ma'am,
we are writing P of X, no, ma'am, what does P refers?
P of x, P is polynomial. Okay? Polynomial in terms of x.
Okay, ma'am.
Okay, this is P stands for polynomial. Polynomial in terms of x. Now this is polynomial in terms of 0. So let's find out this. 5 into 0 will become 0. This will become 0. So we have P of 0 is 3 here. Okay. So that means when the value of x is 0, then polynomial equation becomes equals to 3. Understood this?
Yes,
Same,
ma'am.
same way, if we take value of x to be minus 1, let's take this one now. So in this case also, wherever we have x, in place of x, we will put
ma'am,
minus
answer is 2 for the P into -1.
minus 1 square plus 3. So this becomes minus 5, minus 4, and since this is minus 1 ka power is even here, this will become positive. Okay. So this becomes minus 9 plus 3, that gives you minus 6. Right? Okay, now similarly, now you find for P of 2.
Ma'am?
Yes.
Oh, never mind. Yes, ma'am.
Find the value for P at 2. Do yourself the third one.
Ma'am, P of X at X is equal to 2 will be minus 3.
What it is?
Ma'am,
And the
minus
answer
3.
is -3.
Answer is minus 3.
Minus 3. Yes, ma'am.
Yes, ma'am.
Okay, what is it? This is 4. And this is 2. So this is 4 square. 2 square is 4. 4 4 is 16. This is 3. Okay, 10 plus 3 is 13 minus 6. You get minus 3. Okay, good. Nice, better. So this is when we are given some numbers, we just have to find the value of the polynomial at that point. Okay. These questions were like that. Now let's come to another question type 2. What is another way of asking these questions? Now they have told us find, in the second question it is written, find P of 0, P of 1 and P of 2 for each of these equations. So what are these?
Ma'am, so we should do the means can we take 0, 1, 2 in the form of the variables in the place of the variables?
Yes, yes, that's what you have to do. Okay, that's
Okay.
correct. You have to do that only. So this is the polynomial equation in terms of y now. Now in place of y, you will take these values. First, you will take P of 0. You will find this equation for P of 0. Then you will find it for P of 1. Then you will find it for P of 2. Similarly, for all other equations, on all other sums, you will do the same time. Right? Do it for this one. What do you get your value when you have P y equals to?
Ma'am, 1.
Huh?
1.
1. Okay, because first term will become 0, second is also 0, you just have 1. Okay. Then next,
Again 1,
again 1.
Yes, ma'am, again 1.
Next,
3,
Ma'am, 3.
This becomes 2 square, that is 4 minus 1 plus 1. So that's 5 minus 1. No, this is 4. 2 square, no? P of 2.
Ma'am, 2 square is 4 minus 2, which is
Okay, minus
2
3.
plus 1.
1. So this is 2 plus 1, that's 3.
Yes,
Okay,
ma'am.
good. So similarly, you can find for the remaining questions. Can you do for homework that?
Okay, ma'am.
Okay,
Okay, ma'am.
try yourself. Okay, because once you try yourself, that you will build your confidence. Okay. Question number 3, verify whether the following are zeros of the polynomial or not. Okay. Now here polynomial equation is also given, zeros are also given. You just have to verify whether those zeros are actually the zeros of the polynomial, that you have to verify. Okay. So let's see, verify. This is to be verified. Let's see the, I'll give you this. Let's see the first one. P of x is given as 3x plus 1. It's a small polynomial equation. And the zero of the equation is given minus 1 by 3.
Ma'am, in the equation should be, means in the RHS should we write a 0?
So that means, what do we call zero of a polynomial? Zero of a polynomial is that
Root.
point of x at which polynomial equation becomes equals to 0. That means this equation should become equal to 0. Now you put the value of x here in place of x minus 1 by 3 plus 1.
Ma'am, yes, ma'am, it satisfies.
If 3
This one
cancels,
is 0.
minus 1.
Ma'am, it satisfies the equation.
Okay. Yes, Sampath?
Ma'am, yes, it will satisfy the polynomial.
Not getting you. The voice is not clear. Maybe the fans are
Ma'am
not.
is telling yes, it satisfies the equation.
What?
Ma'am is just telling it satisfies the equation.
Still not getting you. Please write in the chat box.
Ma'am, I was saying that we'll get 0 is the answer, ma'am.
Well, whatever. Yes. Okay. In place of x, you just have to find the value of x here. Right? So if your equation becomes equal to 0, that means this value of x is the 0 of a polynomial. It's verified now. Okay. So this is now verified. Okay. I'll show you one more of this type. Then I'll give you some questions to do. Now let's do for this. Now this is given, P of x is x plus 1 into x minus 2. Okay, now x is equal to minus 1 and 2. Now look here. Here we are given two values of x. Now we know that x has two zeros only when the equation is quadratic. That means this equation is quadratic. But it is given like this in brackets. So we will just open the bracket and make this equation to a proper quadratic polynomial equation form. So we multiply x with x minus 2. Then we have plus 1 multiplied with x minus 2. We get x into x square
Ma'am, x square plus 2 minus
square
2x plus
plus
x
x minus 2.
minus 2.
This
Ma'am, we can
becomes-
simplify it.
Yes. So this becomes x squared and 1 minus 2 becomes minus of x when you have minus 2. Now you can, this is your now polynomial equation, okay? A quadratic equation now, because its degree is 2 now. Now one by one you can just put the values and check whether it stands true for these values of x. Okay? Check now.
Can you explain again?
Yes. See here, P of x is given in the form x plus 1 into x minus 2, right? And you are given two values of x. You are given two zeros of x. Now here we know that when we have a polynomial equation has two zeros only when the equation is quadratic. Quadratic means its highest power is 2. So to bring it in that notation, what we will do, we will just open these brackets. We will multiply them. First, this x will multiply with whole of this term, x multiplied by x minus 2 and plus 1 multiplied with x minus 2. Okay. So we have x square minus 2x plus x minus 2.
Ma'am,
Okay.
ma'am,
And
in the
what
first one, in which the 0 of the polynomial is minus 1, it's
Oh.
false, whereas 2 in the second one, it's true.
Okay. Okay, no worries. It can happen like that. So this becomes positive 1, then positive 1, then minus 2. So this is 2 minus 2, it's coming 0, beta. It's
Okay,
coming
ma'am.
0, no?
I don't have to check it.
Now in place of x, now for finding p of 2, we have 2 square minus 2 minus 2. So this becomes 2 square is 4 and minus 2 becomes minus 4. So this also becomes 0. So both are solutions of the equation. Okay, both minus 1 and 2 are the zeros of the polynomial equation. Okay, great. So you understood now, Pranav?
Yeah, ma'am.
Yes, ma'am.
Okay. Now do one yourself now. Do this part. There are many parts in this. The remaining exercise I'll give you for homework, but for now you just do one question. I'm giving you this one. P of x equals to 3x square minus 1, where you have value of x is given as minus 1 by root 3 and 2 by root 3. Okay, you find for these two values.
And for the first one, minus 1 by root 3, it is 0 only now.
Okay, minus 1 by root 3 is the 0. Okay.
Ma'am, for the second one, it doesn't satisfy.
Ma'am, the second one I'm getting as 1.
Second one is not coming 0. So maybe it is
No,
not.
ma'am.
Okay, let's try. It happens, never mind. If it is happening like that, it can happen. It can be that one is a 0 and other one is not a 0. Okay. So let's do in place of minus 1 root over 3 square minus 1. So this becomes 3 into minus 1 square will be 1 by 3. So this cancels. So this is 0. Okay. Next one is 2 by root over 3. So 3 into 2 by root over 3 square minus 1. So this becomes 3 into 4 by 3 minus 1. So 3 cancels, 4 minus 3 is 3. So that's okay. That means minus 1 by root 3 is the solution of the equation and 2 by root 3 is not a solution of the equation. Okay? Okay? So for this you
Yes,
can
ma'am.
say, for this you can say, yes, this is the solution and this is not a solution. Okay?
Okay, ma'am.
So coming to question number 4 now. The remaining parts I would like you to do as a homework. So your homework today will be do all questions of exercise 2.2 and the examples before this exercise. Okay? And the examples before this exercise. All examples and all the remaining questions. Question number 4 now. This is now find the 0 of the polynomial in each of the following cases. Now see, so far we were doing all these sums where we were given 0. We were given the 0, we just had to verify by putting in the equation. But in this question now, It's only the equation that is given to us and we are asked to find the zero. Find the zero of the polynomial. Okay. So this is find the zero of the polynomial. Let's see the first one. Polynomial equation is given to the x plus 5. This is a small polynomial equation given. Okay, we just have to find the value of x here. For what value of x, this equation becomes equal to 0. Are you understanding? Yes, children?
Yes, ma'am.
For what value of x will this equation become equal to 0? So for what value of x will it become 0?
Ma'am, we can transpose 5
minus
to
5.
the other
Yes,
side.
we
Minus
transfer
five.
this 5 to the other side, it becomes minus 5. So that means if we have x equals to minus 5, we can have left hand side equals to right hand side. Check करना है तो check करके भी आप देख सकते हो minus 5 plus 5 will give you 0. Okay?
Yes,
Done?
ma'am.
Okay, this much is required here. Okay, let's take one more exercise, one more sum here. I'm doing this third one. Okay, third part. That is P of x is equal to 2x plus
Ma'am, I have a doubt.
yes.
Ma'am, can one polynomial equation have more than one zeros?
See, more than one zero is quadratic polynomial and cubic polynomial. Linear equation can have only one zero. Quadratic polynomial can have two zeros. Cubic polynomial can have three zeros. Okay?
Okay,
Okay?
ma'am.
Ma'am, minus 5 by 2.
So if we equate this to 0, then for which value of x, that will be, we take minus 5 on the other side. Okay. So we take 5 on the other side, it will become minus 5. And then 2 is again here, we will take 2 also on that side. It will become divide here. So it becomes minus 5. Okay, that's all. So we'll do the next one. Now you do this. If I have a polynomial equation P of x equals to Cx plus D. Now C is some number which is not equal to 0. Okay. C and D are real numbers. C and D are some real numbers. So find here what will be the value of x.
Ma'am, minus d by c.
Yes, minus D by C. So when you equate this, that means for what value for x, you will get this equation as 0. So that is, you take D on the other side, this becomes minus D. C also goes on the other side, it gets divided. So it becomes minus D by C. Okay? Okay, children?
Yes, ma'am.
Okay. So with this, we are done with most of the questions from exercise 2.2. And the remaining ones, the leftover ones, I want you to try today as a homework. Okay? Okay,
Okay,
now
ma'am.
coming to the next part of the chapter, that is remainder theorem. Remainder. Now remainder क्या है? Remainder का नाम तो हम सभी जानते हैं, है ना? We know all that. Remainder होता है जब हम किसी चीज को किसी और चीज से डिवाइड करें and we get some remainder. Whatever answer we get, that gives us the remainder. Whatever is the left one. Is that if we divide 5 by 2, so what do we get? 2 2s are 4 and 1. Now this 1 is the remainder. ये हम सबको पता है. And this part is called dividend. Okay. This part is called divisor. And this part is called quotient. Is it? Everyone knows this? Everyone knows this?
Yes, ma'am.
So we write here dividend is equal to divisor into quotient
Please remember.
plus remainder. Yes? ये हम सबको
Ma'am, you have to write the divisor and quotient in brackets.
divisor and quotient in brackets. Why
Or else
bracket?
yeah, ma'am, it could be left.
Huh? Why bracket?
Sorry, ma'am.
नो there's no issue in that, कोई बात नहीं, ऐसे भी लिखा तो भी चलेगा, ब्रैकेट भी लिखे हुए तो भी चलेगा. Okay.
Okay.
So the main thing that I'm trying to tell you is dividend is equal to divisor into quotient plus remainder. So this is nothing new for you. You have been doing this from your maybe from class 1 or 2. Okay. But what the remainder theorem says. अब remainder theorem हमें क्या कहना चाहती है? Remainder theorem tells us that if suppose I have some polynomial, any polynomial, and I divide this polynomial equation with some another polynomial, a small polynomial, say x minus a. इसको हम generally x minus a की form में लेते हैं. If I divide this polynomial with another polynomial x minus a, I get remainder which is p of a. I get this remainder as p of a. Okay. This is what remainder theorem tells me. Okay. Now, in your book, you have your book. Please read, go through the statement of the remainder theorem. The statement of remainder theorem says that let Px be any polynomial. Okay, Px is any polynomial of degree greater than or equal to 1. Okay, Px की जो degree है that can be greater than or equal to 1. यानी कि it can be linear, quadratic or any cubic polynomial.
Ma'am, is remainder theorem also called as factor theorem?
Factor theorem is different, बेटा. अभी हम remainder theorem की बात कर रहे हैं. We'll come to factor theorem part also.
Ma'am, where is it actually? In which page actually? I don't know.
What? Remainder theorem?
Yeah, ma'am.
Remainder theorem is NCERT. In my book, it is page number 39. I don't know what is your book.
Okay, ma'am. I am also using the NCERT, but I think I have
Maybe the
no
page numbers may be different. Okay. It depends on the edition also. You may be using the current edition. I'm using the old edition. Okay. Not so old also, but
Yeah, ma'am. In this, I do not think there is remainder theorem.
there is no remainder theorem.
Yeah, ma'am. Check that.
ऐसा हो ही नहीं सकता.
Ma'am, I will check again, ma'am.
हाँ. चलो अभी आप पहले यहाँ सुन लो, बाद में लेटर ऑन यू कैन चेक. ठीक है, अभी आप यहाँ देख लो. आई एम एक्सप्लेनिंग द स्टेटमेंट ऑल्सो. ओके. और जब मैं आपको ये एक्सप्लेन करूंगी ना तो इसके बीच में फैक्टर थ्योरम भी आपको पता चल जाएगी. ओके. नाउ आई एम नॉट टेकिंग द नेम ऑफ फैक्टर थ्योरम. जस्ट फोकस ओनली ऑन रिमाइंडर थ्योरम. ओके. सी नाउ if px is any polynomial of degree greater than equal to 1 and let a be any real number, and a क्या है? A is any real number. If px is divided by the linear polynomial x minus a, then the remainder is p of a. Okay, if the polynomial px is divided by any polynomial x minus a, then the remainder is p of a. ये बोला उन्होंने. ठीक है, कुछ समझ आया? px divided by x minus a gives the remainder pa. ये हमारी रिमाइंडर थ्योरम हमें कह रही है. ओके.
Yes, ma'am.
That means if px is the dividend, if I divide some px with x minus a, okay, it is saying that my remainder is p of a. ये कह रही है. Okay.
Ma'am, what is A in this?
A is some real number. A is a real number. Okay.
Okay, ma'am.
P of x, we can write it as this is the divisor. Divisor. और क्या होता है? We know this statement. No? Dividend is equal to divisor into quotient. Now quotient will be some number. यहाँ पे कुछ होगा number. We don't know that. हम इसको qx मान लेते हैं. Quotient, some quotient here. And this is the remainder which we are asked. So this equation is written like this. Okay. Understood? Px is some
Yeah,
polynomial divided by another polynomial x minus a, and we get the remainder p of a. This is the statement of remainder theorem. बस इतना सा काम है remainder theorem का. और जब कोई चीज डिवाइड होती है तो we always write it in this form. Dividend is equal to divisor into quotient plus remainder. But in this case, we did not know what is the quotient. है ना, यहाँ पे खाली space था. So we just knew the dividend, we know the divisor, we know the remainder. तो हमने quotient को हमने QX लिखा. Okay? Yes?
Ma'am, in the new textbook, actually, there is only factor theorem and algebraic identities.
Okay,
After
no
that, the
problem.
chapter ends.
अच्छा, कोई बात नहीं. You just listen to us. ठीक है? I'll come to the factor theorem also. Okay, now remainder. अभी मैं आपको लिख देती हूँ यहाँ पे what is the remainder theorem statement. You can note down also. ठीक है? This is just what the statement tells us. इसको मैंने ऐसे form में लिख दिया. Now I'll write the book form here. Let Px be any polynomial of degree greater than or equal to 1 and let A be any real number if Px is divided by the linear polynomial x minus a, then the remainder is P of A. Okay, this is the remainder theorem. Right, children? Now you have the statement of the remainder theorem and you have the explanation of the remainder theorem. Okay? ठीक है? What is remainder theorem? Now, अभी हमें remainder theorem कहना क्या चाहती है? ठीक है, it explained us कि we get this remainder. Then what? What do we do with this remainder? Now, remainder theorem हमें ये कहना चाह रही है कि we can find the remainder of anything. We can divide two polynomials even by by not dividing also we can find the answer. Just by using this theorem we can find the answer of this polynomial by dividing two polynomials. We need not need to divide two polynomials. Even without dividing two polynomials, just by using remainder theorem, we can have the answer. Okay? I hope you are understanding this.
Yes, ma'am.
No? Okay, so we practically need to divide the polynomial and check ki kya hai answer. Even without dividing, just by using remainder theorem, we can find the answer of two polynomials being divided. Okay, so we'll work on this in the next class, right? Okay, children. So the class time is over. We'll do some questions on remainder theorem and we'll see factor theorem also. Factor theorem भी इसी में cover हो गई है, but now you just focus on remainder theorem. Now I'll tell you which part is the factor theorem. Factor theorem is exactly the same. Okay.
Okay.
Yes, ma'am.
Okay, children. Bye. Thank you.
Bye, ma'am. Thank you.
Bye, Vita. Bye.